Hello everyone. In this video we will look at section 6.3 and 6.4, starting with 6.3, which is arc length. Now this section is very simple, very straightforward. There's only one thing you need to understand. So let's start with an introduction. Okay, so arc length, just by the name of this, is we want to figure out the length of an arc, right? So for example, if we want to calculate the length of this blue line, let's say from point A to point B, right? The way we do it is we cut this blue line into different segments, and then we guess its distance by drawing a straight line through it, right? Drawing a straight line to it, right? So all these red lines, they are estimates of how long the blue segment is, right? So we are using red to estimate blue. Now, you might say that, okay, of course, this is not going to be very accurate, right? So what if we make, for example, the points between, the distance between each point very short, right? Let's say I cut it right here and make that my P1, then I might have a better estimation of the arc length, right? So anytime you see cutting segment or cutting from point A and B, we're cutting it into very small pieces, that's when we can use the idea of integral. Okay, so this is what we're looking at. We want to find the distance between any given 2 points on the line, and with the idea of delta y and delta x, so changing y and changing x. So we can make it very small and then add all those little segments up together, right? So that's the idea. Now, in order to do that, we have to apply integrals, and this is the only formula that you will need. Okay, so we will be using this formula throughout the section. Okay, so let's get started. Okay, so first, arc length formula, let's write it down again, is the integral from point A to point B, right, on the line that you want to find the distance of, square root of 1 plus f prime of x square dx. And that's it, right? So give you a quick example. Let's look at example 1. Find length of curve of the line y is equal to 2 over 3, 1 plus x squared to the power of 3 over 2. And we want to find the distance for x between 0 and 3. All right. So first we need to find f prime, or dy dx. Right, so let's do that. Dy dx is equal to 2/3 times, bring down the power, 3 over 2, 1 plus x squared, subtract the power by 1, and then we get 1/2, and then the chain rule of the inside, which is 2x. All right, so that's gone. We get 2x times 1 plus x squared to the power of 1/2. Okay? And then you just need to put that in here, right? So capital L for arc length is equal to integral from 0 to 3. Right, we're looking at the arc length from x between 0 and 3. Square root of 1 plus 2x times 1 plus x squared to the power of 1/2. This whole thing squared. Okay, and let's see what we have. From 0 to 3, square root 1 plus 4x squared times 1 plus x squared dx. Forgot the dx here. All right, let's clean this up a little bit. All right, this is what? 1 plus 4x squared plus 4x to the 4th power. 4th power, right? And we can actually factor this. This is a perfect square trinomial. That means we can write it as 1 plus 2x squared quantity squared dx. And that will be, cross that out, 1 plus 2x squared dx, right? And it's pretty simple, right? That's just x plus 2x to the third power over 3, evaluating from 0 to 3, which is 3 plus 2 times 27 over 3 minus 0, right? 0 in both of them are 0. So that's what? 3 plus, it's 9, 18. So 21. And that's your arc length, right? Very straightforward, right? You're given the line or the function, and then you're given the x value, right? The segment of the x, and then you just plug everything into the formula, and then you'll get the arc length. Okay, let's look at another one. So we're looking for arc length. We have the line y equals to x squared minus ln x over 8 and x between 1 and 2. So another approach to do this is, we know that the formula for arc length, let's write it down again. That is b 1 plus f prime of x quantity square. Right. So one technique is we can work out everything in here on the side, and then when we're done, we can just put it back in. So let's try to do that step by step. All right. So first, let's begin by looking for dy dx, or f prime, right? Okay. So that's pretty straightforward. It's 2x minus 1 over 8x. Right? Yeah. Pretty good. All right, so next let's look for the square part, right? So squaring all these, dy dx quantity square. That means we want to square the whole thing. 2x minus 1 over 8x square, which is 4x square, let's see, minus 1 half. Yep, minus 1 half plus 1 over 64x squared. Yeah, I think that's right. Okay. And then after we square that, we need to add 1. All right, so add 1, dy dx square, 1 plus that. So add 1, we can just make that into a plus 1 half. Plus 1 over 64x squared. Okay. So if you look at this very closely, we can actually factor that, right? That's a perfect square, that's a perfect square, right? So the first term is 2x squared, and the last term is 1 over 8x squared, right? The middle term, if it's 2 times that times 2x and 8x, then we get ourselves a perfect square trinomial, right? Let's check, right? So 2 times 2x times 1 over 8x, right? X cross out, that's 4 over 8, which is 1 half, okay? So this is actually plus 2 times 2x times 1 over 8x. This means we can factor that into 2x plus 1 over 8x quantity square, which is very nice, right? Because we want to put this thing inside a square root, right? And let's see what we have. Okay, so put it back in there. Pick a different color. Starting from 1 to 2, 2x plus 1 over 8x quantity square dx, right? And that's just 1 to 2, 2x plus 1 over 8x dx. Let me move to this side. I have a little more space here. So integrate that. That gives us x squared plus 1 over 8 ln x, right? That looks good. Okay, and then we are evaluating this from 1 to 2. Let's see what we have. All right, so 1 plus 0 minus, oops, not 1, 4 plus ln of 2 over 8 minus 1 plus 0, right? So what does that give us? 4 minus 1, so 3 plus ln 2 over 8, right? And that's it. That's your arc length. Very straightforward, right? Just applying the formula. All right, and that'll be it for 6.3. All right, 6.4, we're looking at areas of surface of revolution. So let's start with something simple. Right, if you take a strip of, let's say, a rectangular piece of paper, and then put them in a circle like that, right? Then we're wondering what's the area of this circle, right? And by stretching out, we are actually just looking at a rectangle, right? So if you look at figure A, we have the width of the rectangle is actually just delta x, right? The change of x value from point A to point B. Now the height or the radius of the circle is going to be y, which is the function value, right? Now let's say if we want to find the circumference, oops. 这里开始 the bebe. So we want to find the circumference of this purple circle right here is going to be the radius, which is y multiplied by 2 pi. And when we stretch it out, that will be the length of the rectangle, right? 2 pi y, because that's the same as the circumference of this circle. Right? And to find the area, we just multiply the length and width, which is the circumference of the circle multiplied by the change in the x value, right? That's the pretty easy approach, right? So let's say we have something a little more weird, right? Let's say it looks like almost a cone, like a part of a cone. Right. So what we can do is do the same thing like we were doing arc length. Maybe cut this up into different pieces, and then those pieces can be stretched out as like a rectangle, right? And notice that it says not to scale. Right. So the same idea. The width is going to be the displacement of x value, right? The difference in x value. Right? And then the length is still going to be the circumference. So we're going to do the same thing. We're going to cut this up into many little pieces and look at each piece and stretch it out as a rectangle strip, and then add all of them together. Right? And the idea of adding all of the strip together leads us to the idea of integration. Right? So let's see. Right, so another similar idea, right? We're going to cut into very small pieces and then do that to the whole x value, right? From A to B. Okay. And this is the idea of the math behind it, right? We have the arc length, and then we're going to make it really small to get the different, the width of the strip before we actually rotate it and find the areas of revolution. All right, so here we have it. This part is your arc length, right? Arc length. Right? And then if we look at the arc length on a strip, that's this part, right? That's the width of the rectangular strip, right? And then this part is going to be your length, right? And then we're doing that from point A to point B in the x direction, and then adding all the strip together to get the surface area of revolution. Now, of course, we can also do the rotation in a different direction. Right? For example, if we want to rotate it about the y-axis, then it's going to be a little different, right? Your strip will look like this now, horizontal instead of vertical, and this part is your arc length, which is given by this part, right? L, right? And then the length of the strip is given by 2 pi x, right? And then you're going to add all of the strip together, right? Maybe you have that many strip from C to D, right? In terms of the y value. Right, so to give you guys a quick overview, right? We have basically the different formulas or different ways to find the area of surface of revolution depending on the situation. Right, so if it's about revolution about the y-axis, right, we can use any of these two forms. Right, now the main difference is first the bounds. Right, so here the first form, if it's revolving about the y-axis, the first one, the bound is actually in terms of x, right? X between a and b. And this part is also dy dx, which means if you're given a function f of x or y in terms of x, we can use that. Whereas this one is in the difference of y values, c to d. And then you can see that here we have dx dy, which is x in terms of y, right? So g of y, for example, would be in this case, and here it will be f of x. Right, so any of these will work depending on the situation that is given, right? And the second part is revolve about the x-axis, x between a and b, right? So the first one, we have x between a and b, and then f of x right here. And for the second one is in terms of y, right? And that will be a function of y, let's say g of y, right? And then the main difference you're going to see is that this part right here is going to be different, right? Here we are using the actual function f of x, but here we're just using the variable y. Same thing here. For this one, we're using the function g of y, whereas here we are just looking at, we're just using one independent variable x by itself. Okay, so depending on the situation, we can use different formulas. All right, so let's look at our first example. We want to find the area of surface revolution formed by revolving function f of x equal to x squared, x between 0 and rad 2, about the y-axis. Okay, so we have a function in terms of x, and we want to revolve it around the y-axis. Let's see which one we need to use. Okay. All right, so first we are revolving about y-axis, and we are given the function f of x, right? So we will be using this one right here, okay, the first one. Right, so let's just copy this over. All right, here we go. So we have our surface area is equal to going from A to B, 2 pi x, and square root of 1 plus dy dx, or f prime square. All right, so we have everything we need. Let's go ahead and move on. So 2 pi, can put it in the front. 0 to rad 2 x, and times the square root of 1 plus dy dx, that's 2x, right? 2x squared, that will be 4x squared dx. Okay. All right. So in this case, we probably use substitution, right? Because the derivative of that will be ax, and we have x here already, so we just need and 1 over a out the front. Right, so let's do u substitution. Okay. Let's say u is 1 plus 4x squared, du will be 8x dx. So du over 8 will be equal to x dx. Right, so we can take care of the x here and the dx here. All right, so with u sub, let's see what we have. We have 2 pi. Right, and that's where we bounce later. X dx will be du over 8. Right, so we have 1 over 8 here, and then du. So Next, the seeing 1 plus 4x squared, that's u. So square root of u, I'm going to write it as u to the power of 1 half. All right, let's move on to working with the bounds. Right, so x equal to 0. U will be 1 plus 0, right? So that's 1. And x equal to rat 2. That will be u equals to 1 plus 4. And then square root of 2 square. That's 2 times 4, 8 plus 1, 9. Okay. So u is going to be going from 1 to 9. 1 to 9. Right. I'm going to pull out the 1/8, put it in the front. So we have pi over 4 out the front. And then integrate that, adding power. So u to the power of 3 over 2. And then divide by 3 over 2. That gives us 2 over 3. And then we want to evaluate this from 1 to 9. Okay, so pi over 4. Let's see, when you plug in 9, square root of 9 is 3. 3 to the third power is 27. Over divided by 3 minus 1, that's just 2/3. Okay, all right, let's see what we have. So that's 54. Right, 54 minus 2, 52. All right, so pi over 4 times 52 over 3. Let's divide by 2, that's 26 and 2. So, and then divide again, 13. That'll be 13 pi over 1 times 3, which is 3. Right, so 13 pi over 3. Okay, just need to figure out which formula to use. All right, let's try another one. Okay, we have a function in terms of y, right? X is equal to 1/9 y squared plus 2, right? So we can see this as g of y, right? And then y between 2 and 6 revolve about x-axis, all right? So let's go back to the formula sheet and let's see which one we're going to use. All right, so revolve about x-axis right here, and we are given g of y, x in terms of y. So we're going to be using this one right here. Okay, all right, let's go back. All right, so let's write down the formula we're going to use. Surface area is equal to 2 pi, going from C to D, y times 1 plus dx dy, quantity squared dy. All right, so here we go. Let's actually find out what this part is first. Okay, so dx dy is going to be 2/9 of y. Yeah, that's it. And then square that. Dx dy quantity square be 4 over 36y squared. Oh, not 36, sorry. 81y squared. Okay, and then 1 plus that. All right, so let's put it back in here and see what we're working with. 2 pi, and then bounds 2 to 6. Y, square root of 1 plus 4 over 81 y squared dy. Okay, so this looks nice, right? We can use the same idea, work with u substitution, right? But actually, before u substitution, I want to clean this up a little bit, make it look a little nicer, right? So I'm gonna combine the inside the radical into a common denominator, so that'll be 81 plus 4y squared all over 81 dy. Okay, and now this 81 in the denominator, we can bring it out, and then that'll be over 9, and then we can put it in the front. All right, so it will look like this: 2 pi over 9, integrate from 2 to 6, y times the square root of 81 plus 4y squared dy. Now, of course, you don't need to bring out the 9, right? You can just move on and start U substitution here. Okay, but I like to make things look a little nicer before I move on, right? If it's easier to work with, then that can avoid some mistakes. All right, so U sub, all right, let's do that. U is 81 plus 4y squared. Du will be 8y dy, and then du over 8 will be y dy. Okay, so same thing as the previous one, right? Let's see, 2 pi over 9, all right, and then the bounds, of course. Y dy is du over 8, so we have 1/8 here, du, and then the inside is still u to the power of 1/2. Right, so you can see that we're actually running into something similar to our example 1. Right? In fact, these type of problem, there's not much trick to it. It just depends on what type of function you're working at, and then which formula you're going to use. All right, so let's look at the bound. Y is equal to 2. All right, u is 81 plus 2, 4, 16. That's what, 97. Okay. And y is equal to 6. All right, u will be 81 plus 4 times 36. Oh gosh, that's a huge number. That's 72, 144. So 81 plus 144. That's what? 225. Is that right? Yep, looks good. All right, let's keep going. All right, so bring out the 1/8. So I have 2 pi over 8 times 9, 72. Oh, oops, forgot to fill in the bounds here. Okay, 2 pi over 72, and then that's u to the power of 3 over 2, and then divide by 3 over 2, that's 2/3, going from 97 to 225. Okay, that's huge, right? All right, so let's see. I'm gonna bring out the 2/3, put it in the front. Let's see what we have. So that's 36, 1, and then the 2 here, that's 18. So 18 times 3, that's 54. So we have pi over 54 on the outside. And then here we just need to worry about the u. Right, so u to 3 halves, 225, 297. So I'm just gonna write it out, not bothering finding what it actually is. So 225 to the power of 3 over 2 minus 97 to the power of 3 over 2. Okay, and that's our final answer. Now, of course, if you want, you can always type that into the calculator to get an approximation of the value. But for this class, putting your final solution in this form will be enough. All right. Okay, so this one is for you to try on your own. We have function in x of x is equal to radical x. X is between 4 to 9. We want to find the surface of revolution when it's revolving about the x-axis. Okay, so we're not going to do this one here. Instead, we're going to do this one together when we meet for group work. All right, so definitely give this one a try. And maybe I should give you the solution as well. So surface area is pi over 6 times 37 to the power of 3 over 2 minus 17 to the power of 3 over 2. Okay, so give that a try, see if you can get that, and I'll see you next time.